When replacing a 120-volt lamp and cord assembly in older pools not originally equipped with GFCI protection, several factors must be considered according to the National Electrical Code. First, the installation of GFCI protection. If the pool was not originally equipped with GFCI protection, you are required to install it in the branch circuit supplying the light. Simply replacing the lamp and cord assembly without installing GFCI protection is not sufficient. GFCI protection can be added through a GFCI circuit breaker in the electrical panel or a GFCI receptacle near the pool equipment. Second, consider replacing with a low voltage assembly. You are not required to replace the existing flush mount deck box with one that meets vertical requirements. However, it is recommended for safety and convenience to install a low voltage 12 volts or less lamp and cord assembly. Low voltage systems are safer near water and require less maintenance. Therefore, the Morse code compliant and recommended option is to install GFCI protection and replace with a low voltage assembly. The National Electrical Code (NEC) provides specific guidelines for electrical installations to ensure safety and prevent electrical hazards. For swimming pools, these guidelines are particularly important due to the presence of water, which significantly increases the risk of electric shock. When dealing with older pools that lack modern safety features like GFCI protection, upgrading the electrical system during a lamp replacement is crucial. Let's delve deeper into the key aspects of GFCI protection and low voltage systems for pool lights. GFCI, or ground fault circuit interrupter, protection is a life-saving technology designed to prevent electrical shock. It works by monitoring the current flowing through a circuit. In a typical electrical circuit, the current flowing to an appliance or device should equal the current returning. A GFCI continuously measures this balance. If there is a difference, even as small as 5 amps, it indicates that some current is leaking, potentially through a person to ground. This is known as a ground fault. When a GFCI detects a ground fault, it quickly trips the circuit, cutting off the power in as little as 1/40th of a second. This rapid response can prevent serious injury or death from electric shock. There are two primary ways to add GFCI protection to a pool light circuit. One is by installing a GFCI circuit breaker in the electrical panel. This replaces the standard circuit breaker for the pool light circuit with a GFCI breaker. The GFCI breaker provides protection for the entire circuit, including the wiring and the light fixture. The other method is to install a GFCI receptacle near the pool equipment. This is a special type of electrical outlet with built-in GFCI protection. The pool light is then plugged into this GFCI receptacle. Both methods provide the same level of protection. The choice depends on factors such as the existing wiring, the location of the electrical panel, and personal preference. It is essential to test the GFCI protection regularly to ensure it is functioning correctly. Most GFCI devices have a test button that simulates a ground fault. Pressing this button should trip the device, cutting off the power. If the GFCI does not trip when tested, it should be replaced immediately. Now let's consider low voltage systems. Standard pool lights typically operate at 120 volts. However, low voltage systems which operate at 12 volts or less offer several advantages, particularly in wet environments. The primary advantage of low voltage systems is safety. The risk of electric shock is significantly reduced at lower voltages. Even if a fault occurs, the amount of current that can flow through a person is much less likely to cause serious injury. Another advantage of low voltage systems is reduced maintenance. Low voltage lights typically use LED lamps, which have a much longer lifespan than traditional incandescent or halogen lamps. This means less frequent bulb replacements, saving time and money. Furthermore, LED lamps are more energy efficient, consuming less power to produce the same amount of light. This can result in lower electricity bills. When converting to a low voltage system, a transformer is required to step down the voltage from 120 volts to 12 volts. The transformer should be installed in a dry, protected location away from the pool. The wiring between the transformer and the light fixture must be appropriately sized for the low voltage circuit to prevent voltage drop. Voltage drop occurs when the voltage at the light fixture is lower than the voltage at the transformer due to the resistance of the wiring. Excessive voltage drop can cause the light to be dim or not function properly. The NEC provides tables and guidelines for determining the appropriate wire size based on the length of the circuit and the current flowing through it. In addition to GFCI protection and low voltage systems, there are other important safety considerations for pool lights. The light fixture should be properly grounded to provide a path for fault current to flow back to the electrical panel, tripping the circuit breaker and preventing electric shock. The grounding wire should be connected to the light fixture's grounding terminal and run back to the electrical panel. The light fixture should also be securely mounted to the pool wall to prevent it from becoming dislodged and creating a hazard. The lens of the light fixture should be in good condition and properly sealed to prevent water from entering the fixture. Water inside the fixture can create a short circuit and pose a shock hazard. Regularly inspect the light fixture and wiring for any signs of damage, such as cracks, corrosion, or frayed wires. Replace any damaged components immediately. When working with electricity, always take precautions to protect yourself from electric shock. Turn off the power to the circuit to the electrical panel before working on any electrical equipment. Use insulated tools and wear rubber gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Improper electrical work can be dangerous and may violate local codes. Regarding the flush mount deck box, the NEC has specific requirements for its installation. Section 680.24 addresses the requirements for junction boxes and enclosures for underwater luminaires or pool lights. The deck box serves as a junction point for the wiring connecting the pool light to the electrical system. It must be located at least 4 inches above the ground or pool deck and at least 8 inches above the maximum water level. This is to prevent water from entering the box and creating a shock hazard. The deck box must also be made of corrosion-resistant material and be securely mounted to the pool deck. It must have a cover that is securely fastened and provides a watertight seal. The purpose of the vertical requirements in 680.24 is to minimize the risk of water entering the junction box and compromising the electrical connections. While the NEC does not explicitly require replacing an existing deck box that does not meet these vertical requirements when simply replacing the lamp and cord assembly, it is highly recommended to do so for enhanced safety. Replacing the deck box ensures that it meets current safety standards and provides a more reliable and watertight connection. This is especially important in older pools where the existing deck box may be corroded or damaged. Furthermore, consider the bonding requirements for pool lights. Bonding is the process of connecting all metal parts of the pool and its surrounding structures to create a common electrical potential. This helps to prevent voltage differences between these metal parts, which can create a shock hazard. The pool light fixture, the metal conduit, and any metal parts within 5 feet of the pool should be bonded together using a solid copper conductor. The bonding conductors should be connected to a common bonding grid that is also connected to the pool's reinforcing steel. The bonding grid helps to equalize the electrical potential throughout the pool area, reducing the risk of electric shock. The NEC specifies the minimum size of the bonding conductor based on the size of the circuit conductors. It is important to follow these guidelines to ensure that the bonding system is effective. In summary, when replacing a 120-volt lamp and cord assembly in an older pool without existing GFCI protection, you are required to install GFCI protection on the branch circuit supplying the light. While you are not explicitly required to replace the existing flush mount deck box with one that meets the current vertical requirements in 680.24, it is highly recommended for safety and code compliance. Consider replacing the 120-volt lamp with a low voltage 12 volts or less assembly for added safety and reduced maintenance. Always follow the NEC guidelines and local codes when performing electrical work on swimming pools. If you are unsure about any aspect of the installation, consult with a qualified electrician. Prioritizing safety is paramount when dealing with electricity near water. Ensure that all electrical components are properly installed, grounded, and bonded to minimize the risk of electric shock. Regular inspections and maintenance can help to identify and address any potential hazards before they become a problem. By following these guidelines, you can ensure that your swimming pool is safe and enjoyable for everyone. The National Electrical Code, NEC, Article 680 covers the requirements for swimming pools, fountains, and similar installations. It's crucial to understand these requirements to ensure safe electrical practices. One key aspect is equipotential bonding, which involves connecting all metallic parts within and around the pool to create a common electrical potential. This minimizes voltage differences and reduces the risk of electric shock. The bonding requirements extend to metal parts of the pool structure, metal fittings, metal equipment, and any metal within a certain distance of the pool. Another important aspect is the proper grounding of electrical equipment. Grounding provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker and preventing electric shock. All electrical equipment associated with the pool, including pumps, filters, heaters, and lights, must be properly grounded. The grounding conductor should be sized according to the NEC and connected to a grounding electrode system. In addition to bonding and grounding, the NEC also addresses the requirements for wiring methods. Wiring buried underground must be installed in conduit or be identified for direct burial. The depth of burial depends on the voltage of the circuit and the type of wiring. Wiring above ground must be protected from physical damage and be installed in accordance with the NEC. The NEC also specifies the requirements for the location of electrical equipment. Electrical equipment must be located at least a certain distance from the pool to prevent contact with water. The distance depends on the type of equipment and the voltage of the circuit. GFCI protection is required for most electrical circuits associated with swimming pools. This includes circuits supplying pool pumps, heaters, lights, and receptacles within a certain distance of the pool. GFCI protection helps to prevent electric shock by detecting ground faults and quickly tripping the circuit. The NEC also addresses the requirements for underwater lighting. Underwater lights must be listed for swimming pool use and be installed in accordance with the manufacturer's instructions. The lights must be supplied by a low-voltage transformer or be GFCI protected. The wiring to the lights must be installed in conduit and be properly sealed to prevent water from entering the fixture. Regular inspections and maintenance are essential to ensure the continued safety of swimming pool electrical systems. Inspect the wiring, equipment, and bonding connections for any signs of damage or corrosion. Test the GFCI protection regularly to ensure it is functioning properly. If you notice any problems, have them repaired by a qualified electrician immediately. When working with electricity around swimming pools, always take precautions to protect yourself from electric shock. Turn off the power to the circuit at the electrical panel before working on any electrical equipment. Use insulated tools and wear rubber gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Understanding and following the NEC requirements for swimming pools is essential to ensure the safety of swimmers and prevent electrical hazards. By properly bonding, grounding, wiring, and protecting electrical equipment, you can create a safe and enjoyable swimming pool environment. Remember to consult the latest edition of the NEC and local codes for the most up-to-date requirements. Always prioritize safety when working with electricity, especially around water. If you have any questions or concerns, consult with a qualified electrician or electrical inspector. They can provide guidance and ensure that your swimming pool electrical system meets all applicable safety standards. Regular maintenance and inspections can help to identify and address any potential problems before they become a hazard. By taking these steps, you can help to keep your swimming pool safe for everyone. The most crucial part of electrical work around pools is understanding the equipotential plane, which is described in NEC 680.26. The equipotential plane requires that all metallic parts, including the rebar cage, metal parts of the pool structure, metal components within a specified distance of the pool edge, and electrical equipment are bonded together. This is done to ensure that there is no voltage difference between these parts. Creating this plane mitigates the risk of a shock, which could occur if a person were to touch two metallic parts with differing voltage potentials. Pool lights, in particular, are addressed in NEC 680.23. Underwater luminaires must be specifically listed for pool use and must operate at 15 volts or less. Alternatively, lights operating at a higher voltage, such as 120 volts, must be protected by a GFCI. The installation must also comply with all manufacturer instructions. Regular testing of GFCI devices is essential to verify the functionality as required by the NEC. This is generally accomplished by pushing the test button on the device. If the device fails to trip, it should be replaced immediately by a qualified electrician. The NEC mandates clearances around pools for electrical equipment. This is intended to prevent people from touching electrical devices while in or near the water. Specifically, receptacles must be at least 6 feet from the inside wall of the pool. Other electrical equipment, such as panel boards, must also maintain minimum distances. If it is determined that an existing pool does not comply with current NEC standards, modifications must be made to bring the installation into compliance. This might include adding or upgrading the bonding system, installing GFCI protection, or relocating electrical equipment. Any modifications to the electrical system should be performed by a qualified electrician familiar with pool-related codes. It's important to note that local codes and regulations may further supplement the NEC. Always consult local building authorities to ensure full compliance.